Hello, welcome back. The title of this lesson is called The Interquartile Range of a Data Set. This is part 1. I'm really excited to teach this because it is an opportunity to make something that sounds very complicated interquartile range and make it very understandable for anybody, right? So don't get scared by the title. I promise you that by the end of this, you'll know what the interquartile range is, why we use it, and also how to calculate it. There's a little bit of a process to it, but I promise you it's not difficult, and I really do mean that, right? But it is very important. Now, when we take a look at data sets, there are two main things that we really try to understand about any data set. And I've been saying it over and over again. The first thing is we really want to have some measure of the center point of that data set. We have the mean, the median, and the mode that we have learned to calculate the center, kind of the center value of the data set, right? The second thing we want to know is how spread the data is about the mean. Are all of the data points clumped very close to the mean? Like if you have a class average of 80, are all of the data points, all of the grades, a little bit plus or minus 2 or 3 points of that 80 point average? Or are the grades very spread out on either side of that average, with some people getting 99 and some people getting like 70 and 60s and things like that? So two things: center value of the data set and the spread of the data set. In this lesson, the interquartile range is just another way to measure the spread of a data set. How dispersed, how broad is your data on either side of that middle value? All right, so let me just write some data down here, and we're going to take a look at what it all means, right? Let's take a look at the data 10, 4, 2, 8, 11, 9, 5. Now, what could this represent? This could be the number of trees that we count in the front yard of various houses in a neighborhood. So some houses have 10 trees. That's a really big yard. Some houses have only 2 trees in front. Some have 9. Some have 11. You see the idea. So it's a number of trees in front of various houses that we go sample and take a look at in a neighborhood, right? Now, how would we measure the range of the data, the spread of the data? The way that we have learned before is to just find the range. In that method, we arrange the data from least to greatest. We take the biggest value, we subtract the smallest value. That's called the range of the data set. And then we subtract. So we're not going to focus too much on the range here, but let's go ahead and go through the process of going from smallest to largest, right? So let's go ahead and arrange our data. The smallest value is 2, followed by 4, followed by 5. So 2, then 4, then 5. Put a dot under the 5 there. And then followed by 8, and then 9, then 10, then 11. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 2, 4, 5, 8, 9, 10, 11. Notice that I wrote them down from smallest to largest, and also notice that I kind of gave some space between the numbers. Notice that it was kind of crammed here, and I'm giving a little space here. This is how I want you to do it whenever we actually find the interquartile range. All right, so now we have our data arranged from smallest to largest. And notice that I've given a little space in between each of the numbers, so we have a little room to breathe, and I want you to do that on your paper as well. Now, what is the easiest and simplest way to find the spread of this data? The simplest way is to do what we've already learned and calculate the regular range of this data. All you do for that is you take the largest number, and then you subtract away the smallest number. 11 minus 2 is 9, so the range of this guy is 9. Now, what's the problem with that? The problem is, what if I had an outlier in the data, which happens quite a bit in real life, like an outlier? What if there is some person, this is trees in the neighborhood, that has just really loves trees and never cut them down? He has like 50 trees in the front yard. There's a gigantic field in the front yard. Then you would have an outlier here at 50. And then if you wanted to measure the spread of the data set, you would take 50 and then you would subtract away the 2 and you would get 48. And it would appear that your data is really, really, really broad, lots of spread in the data, because the range would be huge because of that outlier. But the problem is that that range was really only so big because of a single data point called the outlier. So it's the outlier problem. We don't want to throw out the outlier. We want to include it, but we have to have a way to measure the spread of the data without giving so much weight to that outlier, right? And that is one reason we have this interquartile range. So quartile, what does it mean to you? It means, it sounds like quarter, right? Quartile, quarter, right? So I want you to think of quarter. What we're going to do is we're going to break this data set into 4 equal pieces because we're going to cut them into quarters. That's why it's interquartile range, right? We're going to cut it into 4 equal pieces. And what we're really going to do is we're going to say, hey, most data sets probably have some kind of outlier, right? Either on the low end or on the high end, right? So what we're going to do is we're going to cut the data into 25% and then another 25% and then another 25% and another 25%. Cut it into quarters. And then we're going to throw away the upper 25% and the lower 25%. Basically, don't consider them, and we're going to find the range of what is left over. You see, because that way, if there are any outliers, we kind of disregard them for the purpose of finding the range. And that is what the interquartile range is doing. So at a big picture, I want you to understand what you were doing. The reason we don't just find the range is because if we had an outlier, it's going to make the range huge based on one single data point, which could be just an error, right? So what we do is we have this other way of finding the range called the interquartile range. We're going to chop this data set up into 4 equal pieces. We're going to discard the upper piece and the lower piece, and whatever data is left over, we just find the range of that by subtraction. And that's called the interquartile range. And the reason we do it is because by discarding the endpoints of the data, we're kind of getting rid of any outliers that might be on the upper or the lower end. All right, now how do we do this? There's a little procedure to it. This one's actually quite easy, but the problem is, the reason it's easy is because there's 1, 2, 3, 4, 5, 6, 7 data points. And it's very easy when you have 7 data points because it's an odd number. But when you have 4 data points or 8, an even number, it's a little tougher. So I'm going to show you the full way of doing it, and just know that it's a little easier for this problem, but the next problems will be, it's not tough, it's just a little bit, we have to be a little more careful. So what we do is first, we find the median of this data set. Remember, the median is the middle value. Now you know that you have 3 values here. I'll put a little curly brace here. You have 3 values here, and you also have 3 values right there. So if we grab these values and we pull them apart and we have one value in the middle, then we know that we have a median value, because that's what we called it before, the median. And that's equal to 8. 8 is equal to the median. Now, for the purposes of quartiles, we have another name for the median. And you'll understand in just a minute why we call it this, but we have another name for the median. We call it Q2, quartile 2. You'll see why in a second. So I want you to label this median that we just calculated. We call it Q2. And that's equal to 8. So it's the same exact thing. We just renamed the median Q2. Now notice the median was real easy to find here because there was just a single middle value. Sometimes you have to take the middle 2 values and average them to find the median, but in this case we start out a little simpler. So here we find Q2, right? Now we have to go and take a look at the left part of the data and then also the right part of the data. And what we want to do is, of the left-hand 3 pieces, the left-hand side of the data, we want to find the middle value, or kind of like think about it as the median of just these 3 numbers right here. So what is the middle value on the left? What is the middle value on the left? It's 4, right? So what you can do is call this Q1 equals 4, right? Equals 4. Because it's the middle value here. So you can kind of, I hate marking it up too much, but we can kind of put a little box around the number 4. It's kind of an important number. We call it Q1. Then we can go over to the right-hand side here and look at these 3 numbers and find the middle value of this, the median of this, and we're going to rename that. What do you think it's going to be? Q1 is this, Q2 is this, then the middle part of the upper part of the data, we're going to call it Q3, and that's equal to 10. So I can kind of put a little dotted box or something like that around the number 10 to show you that that's important. And then, of course, I'm going to put a dotted box kind of around the... I guess I'll put it down here around the 8 because that's important. So what have we done here? We basically have said that the number 4 is a special number in this data set, the number 8 is a special number in this data set, and the number 10 is a special number in this data set. The leftmost number here, this one we called Q1, quartile number 1, And this one is called quartile number 2, Q2, which is also called the median of the data set. And then this one is called quartile 3. Why do we do that? What these numbers mean, Q1, Q2, and Q3. Remember, I said we want to take the data set and we want to cut it into 4 equal pieces. What this number means is that 25% of your data is less than 4. And then this number means that between Q2 and Q1, 25% of the data is between these two numbers. Notice there's just a single number 5 there. And this Q3, this number 10, as compared to 8, 25% of the data is between these 2 points, and then 25% of the data is greater than 10. Remember, at the very beginning I said quartile means quarter. We want to chop the data set into 4 equal, kind of put it into 4 equal buckets, right? The numbers themselves, don't worry so much about the numbers themselves. What I'm talking about, the buckets are the numbers that are between these, right? So 25% of the data is between, 25% of the data is between, 25% of the data is between, 25% of the data of the data is between, ignoring these numbers here, obviously, okay? I'm saying that of all the numbers that are not circled here, a fourth of them are here, a fourth of them are here, fourth of them here, fourth of them here. So it's like the lower quartile, then you have this quartile, and then the third quartile, and then the fourth quartile is above that, right? Now, why do we talk about all this stuff? Because we said we want to find the range, but by ignoring the upper 25% and the upper 25% is just the number 11, and the lower 25%, which is the number 2. So what we do is we say, all right, we're going to go here, between this number and this number, and we're going to find the range of that. So we're going to say that interquartile, we call it interquartile range. Interquartile range, I'm going to abbreviate IQR, that's what you see quite a bit, is equal to the number 10, this is Q3, minus Q1, minus 4. And 10 minus 4 is 6. So the interquartile range is equal to 6. So all of this work was really just to figure out this single number called the interquartile range. So think about the big picture. If I gave you this data set and I said find the range, this is a regular range of the data, you would arrange it like this and you would take 11 minus 2 and you would get 9. And 9 is the range of the data. That really is the width of the data, how spread the data is. But as I said, we can have outliers in our data. What about the guy with 100 trees in his front yard? Then he's going to make the range very, very big because you will take this number minus the smallest number, and then it will drive the range to be much higher, and it would appear to be much bigger than actually what the bulk of our data is. So we don't really want to count the outliers when finding the range. So what we do is we invent a new range. This new range is found by ignoring the upper 25% of the data and the lower 25% of the data and just finding the range of what is left. So what we do is we first start out by finding the center of the data set. We call it the median, here it is, and we relabel it Q2. Then we take a look at only the numbers lower than the median, and we find the kind of the median of these numbers, which is the middle number, which is just a 4. And then we look at the upper numbers and we find kind of the median of just this, which is a number 10. So now we relabel them. Q1 is 4, Q2 we relabel the median as being 8, and then Q3 being 10 right here. And then we have quartile 1, quartile 2, quartile 3. What it does is it divides up the data set into buckets. 1/4 here, 1/4 here, 1/4 here, 1/4 here. Of course, these numbers are not included in the buckets. The Q1, Q2, and Q3 are the boundaries, but the numbers between Q1 and Q2 and Q3 are what are the 25% buckets. So 25% of the data is bigger than 10, 25% of the data is between 8 and 10, that's just one more number, 25% of the data is between 4 and 8, which is number 5, and 25% of the data is less than 4. And then we ignore the lower quartile, the 2, we ignore the upper quartile, the upper 25% of the data, the 11, and we just subtract these numbers, and we give an interquartile range of 6. The interquartile range means the range of the upper quartile and the lower quartile. That's what interquartile means. So as always, the first problem takes the longest. But now that we know what we're doing, we can be a little smarter and a little faster. Let's take a look at 64, 60, 70, 59, 63, 69, finally 67. What is this? Data could represent the age of retirement of some people in a community. How old are they when they retire? This person retires when they're 70. This person retires when they're 63, for instance. Step number 1, write the data from smallest to biggest. The smallest number in this list is 59, so it goes here. And now you can see why we give ourselves a little bit of space between so it's not so crowded. The next number is 60. The next number is 63. The next number is 64. The next number is 67. The next number is 69. And the final number is 70. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We go from 59, 60, 63, 64, 67, 69, 70. Just make sure I have everything written down correctly. All right, the very first step, we want to find the center of the data set. That's the median. We now call it Q2, but it's just the median of the data set. So we know that we have an odd number of data points, okay? And we can see, just like before, so this is the same size data as before. We have kind of a lower grouping of data, and we have kind of an upper grouping of data, and that reveals that we actually do have one value in the center, right? Now, we've been calling it the median, and it is the median, right? But now we're a little smarter and we know a little more about what we're doing, so we're just going to call it Q2 is 64. Q2 is 64. And because it's one of these special numbers, I'm just going to kind of circle this like this, just so we remember, hey, that's the center of the data set, 64. We call it the median, but now we rename it, we call it Q2. Now we turn our attention to over here, and we look at only these three numbers, and we find the median of this, right? Which is the center number, which is, of course, we can just see we can just read it right off as just 60. And then we can just say that Q1 is equal to 60, right? And then finally, we can look at the upper part of the data, and we can see that we have a middle value very easily to read right here. And so Q3 is equal to 69. So Q1 is 60. And Q2 is 64, and Q3 is 69. So this number 60 is like a boundary, and this 64 is like a boundary, like a wall, and this 69 is like another boundary, it's like a wall. So from here, it breaks the data set up into what's of the remaining numbers. 1/4 of them are below, 1/4 of them are between, just another number, another 1/4 of them are between these numbers, and another 1/4 of them are larger. So it breaks up the remaining numbers in the data set, not including these three that I've circled, but the remaining numbers into 25% buckets, which we call quartiles. This 70 is the only number in the upper quartile. This 59 is the only number in the lower quartile, and these other two numbers are just other quartiles near the middle, near the median there. So finally what we do is we find the range, but not including the lower quartile and the upper quartile. So we go here, and we just calculate the range between those. So we have the interquartile range is going to be Q3 minus Q1, whatever we found for Q3 and whatever we found for Q1. So, and what did we find for that, by the way? 69 minus 60. And that's going to be equal to 9. So the interquartile range is 9. Right? So again, what would be the regular range? The regular range would just be 70, the uppermost value minus 59, right? Which is 11, right? So that would be the regular range, which would be 11. The interquartile range is smaller because we're discarding the upper quartile and we're discarding the lower quartile, and we're only finding the range of Q3 minus Q1 like this. For this particular data set, there's not really an outlier, so the regular range and the interquartile range are very close because it was, remember, 70 minus 59 is 11, so 11 versus, what do we get here, 9. But if we had an outlier, let's say we had somebody who just really worked a long time and they retired at like 95 years old, that would be way higher. It would be a very large outlier. The regular range would be, whatever that is, 95 minus 59, it would make our data appear to have a very wide spread when really it was only one data point making that range so big. So by using interquartile range, we discard any upper numbers. We also discard any lower numbers to get rid of any outliers on the low side, because you might have somebody retire at 25, a millionaire or something at 25 years old. He would be an outlier on the low end. We discard those, we find the range of what is left over, interquartile range. That's why we use it. All right, problem number 3. This one gets a little bit dicier, and you'll see why in just a second. What about the data 7, 4, 2, 0, and 5? 7, 4, 2, 0, 5. What could this data represent? The number of donuts that a person eats every day, or let's say different people eat. So one person eats no donuts on a Saturday. This person ate 2 donuts, another person ate 5 donuts. So it could be like at an office party or something. How many people, how many donuts did each person there actually eat? So we want to first find how to write this from lowest to greatest. So the smallest number here is 0. Let me give myself a lot of room. The next largest number is 2, which is this one. And then we have 4. And then we have 5. And then finally we have 7. So the procedure is the same as before. First we lock down the middle number, which we call the median. Now we see we have 1, 2, 3, 4, 5, 0, 2, 4, 5, 7. So we have 5 data points. And so we know that basically we have a central value. The 4 is the center value. So we can kind of, as we always do, we can group these together and we can group these together. We pull them apart. We have a center value of the data. And so we can label this. This will be Q1, whatever we find here. This will be Q2 is equal to 4. And so because it's one of those special numbers, I will just kind of circle it like this. So this divides into a lower half of the data set and then an upper half of the data set. So that's kind of a boundary, the Q2, which we remember also is called the median. Q2 is called the median of the data set. So then the next thing we do is we look at the lower half of the data and we find the middle value here, also called the median of this guy, which we're going to call Q1. But there is no middle value because we only have 2 data points. What do? Remember we said when we're finding the median and there is no center number, what you do is you instead find the center 2 numbers and you average them together. But here, we only have 2 numbers. So basically what we want to do is find out what is between these 2 here. And so that's going to be Q1. Now, what is between 0 and 2? Between 0 and 2 is exactly the number 1. So you can figure out what should be in the middle very simply, but the better way to do it is to calculate it, just to make sure you're not making any mistakes. So what you do is you go up above here and you say Q1 is equal to, and you average these, 0 plus 2, I guess I'll do it like this, which is equal to 2. And then you say Q1 is equal to 2 divided by, I guess I'll write it like this, 2 divided by 2, because we added them up and we got 2, then we divided by 2 and we got 1. So Q1 is equal to 1. All right, so what I'm going to do then is right down here below, I'm going to write another number right here, I guess, right between these 2. And I'm going to put the number 1 right here because it is between them. And I'm going to circle this like this, right? And I'm going to remind you that Q1 is equal to 1. All right, let's go do the exact thing over here. What is between 5 and 7? When you average them, that's what you're going to get. You know 6 has to be exactly in the middle of 5 and 7, so that's going to be the answer. But the way you really do it is you say, all right, what is 5 plus 7? What is 5 plus 7? That's going to be 12. And then you say that Q3 is equal to 12 divided by 2 because we're averaging 2 numbers. And so we say that Q3 is equal to 6. That's exactly what we said should happen. It should be the middle number right here. All right, and so because it's another one of those special numbers, I'm going to drop down below and right between it, I'm going to put the number 6. And then we're going to kind of circle that like this. And then down below, I'm going to write down that Q3 is equal to 6. Now, what have we done? We've effectively done the same thing that we did before. We have to figure out how to break this data up so that 25% is in the lower quartile, and then another 25%, and another 25%, and another 25%. So we have to find the boundaries. So the middle boundary is just one of the numbers of the data set. 4 is in the data set. But down here, there is no number in the middle, so we find the number in between, which is the number 1, and we say this is a boundary of the data set. Notice that to the left of the number 1 is only one number, that's 25%. Between these 2 numbers is another number, that's another 25% of the remaining data. Between these 2 numbers is a number 5, that's another 25% of the data. And then above the number 6 is another number. So all it is finding the boundaries so that our data, we can put them in buckets, lower quartile, lower middle quartile, upper middle quartile, and then upper quartile. And finally, once we have it all together, we do the same thing that we do anyway for the interquartile range. We say that the interquartile range is equal to the Q3 minus Q1, which is 6 right here minus 1. And so the interquartile range is equal to 5. Just double checking myself. And it is equal to 5. Now, what would be the regular range of this data? The regular range would be 7 minus 0, which is just 7, right? That's the regular range of the data. The interquartile range is 5, so they're pretty close. But that's just because there's no outlier here. If we had, this was like the number of donuts that people eat at an office party. If you had somebody that just loved donuts and they ate 20 donuts, they got sick, that would be an outlier way to the right. If we had the 20 donut eater in the data set, then we would be taking for the regular range 20 minus 0, and the range would be 20. But that range will make our data set appear to be really spread, when in reality it was just one really hungry person who ate a lot of donuts driving the range so large. So by discarding kind of this upper quartile and discarding kind of this lower quartile and finding the range based on what is Q1 and Q3. These numbers are not in the data set, notice. 1 and 6 are not in the data set. They're made up numbers that are the boundaries that divide the data set up, but we can still find the range based on these numbers, and that is a more accurate range when we think we have outliers in the data. That's the bottom line, okay? So interquartile range is used quite a bit, especially when we think we have outliers in the data. All right, we're going to do one more in this lesson. Let's take a look at this data. What about 32? 26 is the next number. 26, and then 24, and then 29, and then 33, and then 27. All right? So what do these numbers mean? It could be anything, but let's just say the age that some people, my friends get married. Some people get married, one person got married 24, another person got married 33, somebody got married at 32, and so on. So let's find the range of this data, or the interquartile range. How spread out is this data? So the very first step is to write this data down in least to greatest. So the smallest number here is 24, right? And then next number up from that is 26. And the next number up from there is 27. And the next number up from there is 29. And the next number up from there is 32. Just make sure, got everything there. And then the final number here is 33. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 data points. 24, 26, 27, 29, 32, 33. Okay, so the very first step is to find the middle of the data set, but notice we have only 6 numbers. So really, when you really try to do it, this is kind of like the lower half of the data, and this is like the upper half of the data. If you pull them apart, there is nothing in the center. So just like when we find the median, which is what Q2 is, we always find the median first, the middle. There is no middle value, but we can still find a middle value. It's just going to be taking these two numbers, the middle two numbers, and averaging them together to try to find a meaningful middle of this data set. Now, what is between 27 and 29? It's got to be 28. We know this. But to calculate it, what you do is you take 27 plus 29. And when you get that, you're going to get 56. And when you take 56 and you divide that by 2, you're going to get 28. You can do the long division off to the side, take 56 divided by 2, or you can multiply 2 times 28 and convince yourself that it equals 56. But you want to check to make sure the answer makes sense. It should be the average of these numbers, which is the number in the middle, and 28 is in the middle. So that is the right answer. So what have we figured out here? We figured out that Q2, which is called the median, is 28. And it's one of those special numbers. Q2 is a special number, so I'm going to box it like this. It forms a boundary. 28 forms a boundary that separates the lower half of the data from the upper half of the data. That's what a median is. Half of the data is bigger than 28, and the other half of the data is smaller than 28. Now, Q1 and Q3 are a little easier because we have 3 data points here, whereas before, when we were trying to do it with this data set, we had to kind of average to find the lower median, Q1, and the upper median, Q3, because we only had 2 points here. But this one is a little easier because we have 3 numbers here. So Q1 is just the median, or the middle value, which is in this case 26. And then Q3 is the kind of the median, the middle value of these three numbers, which is 32. All right, so I can circle this number as being important and this number as being important. So all of this work was really just designed to find Q1 and Q3. And so we have figured out that the interquartile range is equal to Q3 because we throw away the upper quartile, which is just the 33. We throw away the lower quartile, which is 24, and we take Q3 minus Q1. Q3 was 32. Q1 was 26, right? And 32 minus 26, IQR, is going to be equal to 6. If you start at 26 and add 6 more, you're going to get to 32. So IQR, interquartile range, is 26. Right? So again, the idea here of interquartile range is to find a measurement of the spread of the data, the range of the data, but without including the endpoints. Because very often the endpoints are going to have, in this case it was the age at marriage. What if you have like a 60-year-old that got married? Or somebody younger, that may be an outlier as well. And so sometimes when you're trying to find a good measure of the spread of your data or how spread out your data is, you don't want to include those extreme cases because they're extremely rare. They're not really representative of the bulk of the data, so sometimes you just want to throw them away. So you have to find Q1 and Q3 and subtract them because that is throwing away those numbers here. Now, one thing I'll say is some students, they won't really try to find Q2, the median here, because they don't think it's needed because you just need Q1 and Q3. But I'm teaching you this on purpose because in very short order, we're going to do something called a box and whisker plot where we represent this data on a graph, and you're going to need to know Q1 and Q2, which is the median, and Q3 in order to draw the plot. So it's just really smarter here in the beginning to go ahead and find Q1 and Q2 and Q3 and do it in the way that I'm showing you here so that you have all the information. When we get to the next skill, you'll already know how to do it. So don't skip any steps. I mean, you can if you want, but I really like the way this is laid out. I think you should do it this way. Some students want to do it a little differently. As long as you get the right answers, I guess I'm okay with it. But I like the way this is set up because it shows you that this is a boundary. And then this number is between, but it's also a boundary. And this number here is a boundary. And it divides the data into 4 equal buckets. Here's one bucket, here's another bucket. Here is another bucket here because the boundary was between, and here is another bucket up there. We throw away the end buckets, find the range. That's called the interquartile range. Now, it sounds real complicated and cumbersome, but I think by now with 4 examples, you can see how to do it. I'd like you to solve these, all of them. Then follow me on to part 2. We need a little more practice because I'm going to give you some trickier cases, maybe with more numbers, and then we will get a little more practice to wrap up the concept of interquartile range.